Hi, here we have a problem on complex number. That is, we have to write this complex number in standard form. Okay, what is the standard form of a complex number? The standard form of a complex number is a positive bi. Okay, to write this complex number in standard form, that is in the form of a plus bi, first we have to simplify this stuff I to the 20th power, I to the 90th power. Okay, let's do that. Z is equal to 3 times. So here we have exponent 20 for I. Since 20 is an even number, we can write this I to the 20th power as a power of I square. So that is I square whole to the power 10. Because when I simplify this one, I'll be getting I to the 20th power. So because here 2 times 10 is 20, we get I to the 20th power. Okay, here the exponent is 19. It's not an even number, so we cannot write this one as a power of I square. So for that, what I'm going to do is I'm going to write this 19 in terms of an even number. So like I to the power 18 positive 1. Okay, so divided by the denominator is taken as it is, that is 1 negative 2i. So z is equal to, in complex number, we know that the value of I square is negative 1, so negative 1 to the 10th power negative. And this I to the power 18 positive 1 can be written as I to the 18th power times I to the first power. So because already we have we know the stuff in exponent, that is product rule, a to the power m times a to the power n equals to a to the power m positive n. So whenever we multiply terms with the same base, we can take the base ones and we can add the exponents. So I'm just doing this in reverse order. That is, whenever two values are added at the exponent, we can take the base separately for this one, and we have to multiply them. So that's what I've done over here. So because here at the exponent two numbers are added, I'm taking this base I separately for 18 and separately for 1, and I multiply them over here. Okay, now I'm taking the denominator part as it is, that is 1 negative 2i. Okay, here z is equal to, okay, let's evaluate this one. So negative 1 to the 10th power. So whatever exponent we have for 1, it will always result 1, because when 1 is multiplied by itself for any number of times, it results 1. But here we have a negative sign, and 10 is the exponent, common exponent for all the stuff we have inside the parenthesis. So this exponent 10 is applicable for negative sign also. Since 10 is an even number, and when I apply this even exponent for this negative, it will become positive. So the evaluation of negative 1 to the 10th power is just 1. So 3 times 1 negative. And here the 18 is an even number. So we can write the I to the 18th power as a power of I square. So I'll be getting I square whole to the power 9. And this one is just I to the first power is just I divided by 1 negative 2i. Okay, now z is equal to 3 times 1 is 3 negative. The value of I square is negative 1 to the power 9 times I over 1 negative 2i. Okay, z is equal to, here we have exponent 9 for 1. So when 1 is multiplied by itself for 9 times, still it is 1. And also this exponent is 9 is applicable for negative sign also. So whenever we apply odd exponent for a negative sign, it will remain negative. So the result of this one is, the evaluation of this part is just negative 1 times I over 1 negative 2i. So 3 negative times negative will become positive. 1 times I is I over 1 negative 2i. Okay, now we have simplified the stuff that we had in numerator. So to write the complex number in standard form, we have to get rid of the I in denominator. Okay, how can I get rid of this I in denominator? For that, I have to multiply both numerator and denominator by the conjugate of this denominator. So here the denominator is 1 negative 2i. The conjugate of 1 negative 2i is just 1 positive 2i. So I multiply both numerator, denominator by the conjugate 1 positive 2i. Okay, now let's multiply. Okay, here we can multiply these two binomials using FOIL method. So 3 times 1 is 3. 3 times positive 2i will be positive 6i. Positive I times 1 will be positive I. Positive times positive will become positive. And I times 2i will become 2i square. Okay, now it's in the form of a negative b times a positive b. So in algebra, we have an identity that is a negative b times a positive b equals to a square negative b square. So instead of a, in our problem, we have 1, and for b, we have 2i. So for a square, we have to write 1 square. For b square, we have to write 2i the whole square. Okay, let me continue this on the next page. This is the last step we had on the previous page. Okay, let's simplify this. 3 positive 6i and I are like terms, so we can combine them. So when I combine positive 6i and positive 1i, it will be positive 7i, positive 2 times. So the value of I square is negative 1 over the value of 1 square is 1. So here 2 and I are multiplied and we have the common exponent. So whenever two values are multiplied and we have a common exponent, the exponent can be distributed to each value and multiply them. So then I'll be getting 2 square times I square. So z is equal to 3 positive 7i. Positive times negative will become negative 2 over 1 negative. The value of 2 square is 4. The value of I square is negative 1. So z is equal to, we can combine 3 and negative 2. So when I combine 3 and negative 2, it will be 1 positive 7i over 1 negative times negative will become positive. 4 times 1 is 4. So z is equal to 1 positive 7i over 5. So z is equal to, so here 5 is a common denominator for 1 and 7i. So this denominator 5 can be taken separately for 1 and separately for I. Then I'll be getting 1 over 5 positive 7 over 5i. Okay, now the complex number is in the form of a positive bi. So the standard form of the given complex number z is 1 over 5 positive 7 over 5 I.